Hello and welcome to presentation 2 of Electrical Principles and Technology. This is part of the grade 9 science curriculum for Alberta. Electrical safety. Coming in contact with a power transmission line can prove deadly. By touching it, a short circuit can occur because the electricity is trying to find a path to the ground. You can complete the circuit and it may be fatal. Electrical shock. High voltage power lines contain 50,000 volts of electricity. However, amperage is important to consider. 0.001 amps will likely not be felt at all. 0.015 amps to 0.02 amps will cause a painful shock and loss of muscle control, which means you will not be able to let go of the line. Current as low as 0.1 amps can be fatal. Electrical dangers vary depending on the situation. When the current can flow easily, it is more dangerous. Insulators such as wood, rubber, and air hamper the flow of electricity. A lightning strike can have 30,000 amperes, which is more than enough to kill you. Lightning can also do a lot of damage to a building. Metal lightning rods are connected to the ground with a grounding wire fixed on the roof of many buildings to prevent damage to the building during an electrical storm. The Canadian Standards Council issues labels to identify the amount of voltage required to operate electrical devices and the maximum current that they use. You'll often see it as CSA. Electrical safety reminders. Never handle electrical devices if you are wet or near water. Moisture is a good conductor of electricity, so avoid water when working with electricity. Don't use devices that have a frayed or exposed power cord and pull on the electric plug, not the cord. Always unplug an electrical device before disassembling it. Don't put anything into an electrical outlet except the proper plug for an electrical device. Don't overload an electrical circuit by trying to operate too many devices at once. Avoid power lines. Never remove the third prong from a three-prong plug. Avoid being the target of a lightning strike by staying low to the ground or horizon and away from trees. Don't bypass safety products when you are in a hurry. Plugs, fuses, and breakers. The third prong of a three-prong plug is the ground wire connected to the ground wire of the building in case of a short circuit. Fuses and circuit breakers interrupt a circuit when there is too much current flowing through it. Fuses contain a thin piece of metal designed to melt if the current is too high. Circuit breakers, on the other hand, trip a spring mechanism which shuts off the flow of electricity through the circuit when there is too much current. Circuit breakers can be reused over and over provided the cause of the increased flow is corrected. So here is a fuse. Examples of a 20 ampere current, what load it can take, and what happens when it overloads. So here you have a fuse, a light switch, and a power cord. So the light is on. Then you add an iron. Then you add a toaster. As you can see, the fuse is getting redder and redder, so there's more electricity flowing through. It's getting warm. Then you add a blow dryer. You notice that the fuse is getting even more red. Eventually, this fuse will break and no electricity is going through at all. With a circuit breaker, on the other hand, you would have to replace the fuse, but you would just have to flip the circuit breaker back on. An electrochemical cell supplies a steady current. It is a collection of chemicals designed to produce small amounts of electricity. The electricity comes from chemical reactions within the cell. Dry cells. The electricity-producing dry cells, which are referred to as batteries, are called dry cells. They are dry because the chemicals used are in the form of a paste. The chemical reaction in a cell releases free electrons, which travel from the negative terminal of the cell through the device, which uses the electricity, and back to the positive terminal of the cell. The dry cell is made up of two different metals called electrodes in an electrolyte. An electrolyte is a paste or liquid which conducts electricity because it contains chemicals that form ions. An ion is an atom or group of atoms that has become electrically charged through the loss or gain of electrons from one atom to another. The electrolyte reacts with electrodes, making one electrode positive and the other negative. These electrodes are connected to two terminals. Wet cells are called wet because the electrolyte is a liquid, usually an acid. Each electrode, zinc and copper, reacts differently with the electrolyte. The acidic electrolyte eats away at the zinc electrode, leaving behind electrons that give it a negative charge. The copper electrode is positive, but it is not eaten away. Electrons travel from the negative terminal attached to the zinc electrode through the device and onto the positive terminal attached to the copper electrode. Connecting two or more cells together creates a battery, which is a sealed case with only two terminals. So here is an example of a wet cell. You have a copper electrode and a zinc electrode. There's an example of a battery. A car battery is made up of 6 wet cells. Each battery has 6 lead-acid wet cells containing alternate positive and negative metal-plated electrodes in a sulfuric acid electrolyte. Batteries. Dry cells and wet cells are called primary cells. Chemical reactions which produce the electricity cannot be reversed. Rechargeable batteries. In a rechargeable battery, an external electrical source is used to rejuvenate the cells to reverse the chemical reactions. The reversed flow of electrons restores the reactants in the cell. Rechargeable cells are secondary cells because they store electricity that is supplied by an external source. The most common reactions that are efficient enough to be used for these types of cells are nickel oxide and cadmium. The reactants are restored, but the electrodes wear out over time. Pacemaker batteries can last between 5 and 12 years. Fuel cells. Fuel cells combine hydrogen and oxygen without combustion. Electricity, heat, and pure water are the only byproducts of the fuel cell's reaction. They are 50 to 85% efficient. A world leader in fuel cell technology is a Canadian company, Ballard Power Systems in Burnaby, BC. Here are some examples of batteries. The first two: carbon zinc, which you can find in flashlights and portable stereos; nickel cadmium, laptops, shavers, and power tools. Alkaline batteries, which are your common type of batteries. You can find them in things like CD players or toys. Nickel metal hydride batteries you can find in cameras, laptops, and cell phones. Zinc air batteries are found in watches and hearing aids, and lead acid batteries are found in cars.